Hello guys, my name is Deepak Deshmukh. Today we are discuss about optimization loss functions, finding the best fit with gradient descents. Hello guys. In simple word, we explore how a machine learn by the minimizing their mistakes step by step until they find the most accurate solution. Then we see the goal. What is the best fit line and why do we needed it? Defining the best fit. We start understanding the goal uh, of extract by best fit lines. In linear regression, the best fit line is a straight line that minimizes the distance between itself and all observed data points. This line just a mathematical object. It's how we modern relationship between variable. For example, if we plot a study hours on the x-axis and exam marks on y-axis, the best fit line show the trend how more study hour relates to high marks. Uh, why do you need it? First is to modern relationship between variable. Second is to make accurate predictions for new data and to summarize a complex data set in a simple visual forms. Uh, thinks of it as our initial uh, hypothesis about how the data is behave. Gradient descents is a mathematical process that help us refine this hypothesis and get the most accurate line possible. Then we see introducing the loss function quantifying badness in our model. Uh, now that we use something called loss function. It tells us how wrong our prediction are. Formally, the loss function or cost function measure the difference between our model predicted output and true output. If this loss is high, it means our line does not fit the data well. If it small, the line is close to perfect. The most common loss function is regression is in the mean squared error MSE. It is squared each prediction error or coverage or average them. Squaring ensure large error and penalize more heavily. There the entire goal of a training is to find the parameter, the slope and intercept that minimize the lost value. In other words, minimizing the loss equals to finding the best fit line. Then we see visualizing the landscape, understanding the lost surface and their spaces. This visualization happening, imagine the lost function are landscape or a topographical map where the evaluation represent the lost value. There are two main type of surface. First is convex surface and second is non-convex surface. In non in sorry in non in a convex surface shaped like a smooth blow with a single lowest point called the global minimum. This is what we have in a simple linear regression on a clear best solution. In a non-convex surface, a convex surface full of hill and valley. This happen in a deep learning where the optimizer can get a struct and local valley and a local minima. So we take about optimizer. What we really doing in navigating the lost surface, trying to each of button where the loss is minimal. Then we see the journey begins. What is the gradient descent? Imagine you standing blindfolded on a mountain and your goal is reach the valley floor. The lowest point, you can't see where to go, but we can't feel the slope under your feet. The logical thing to do is take small step in a direction where the ground slope downward the most. That exactly what gradient descent does. It is a iterative optimizer algorithm that update the modern parameter step by step, moving in the direction that reduce the loss function the fastest. Then we see the math behind the magic, means a gradient, learning rate, and update. The gradient is a vector of a parameter or a partial derivative of the loss function. Once for each parameter like weight and base, it tells us to slope the directions of a steepest increase in loss. The reduced loss we move in a opposite direction. Opposite directions, the negative gradients. The update rule is theta equals to theta alpha gradient g by gradient theta, where alpha is the learning rate, a small positive numbers controlling how big step we take. If a theta is too large, we overshot and never coverage it too small. We move too smoothly. So the learning rate act as a spacing control of our optimization journey. Now we see the example step by step of gradient descent in action. Our first step is to start at a random point. We initialize and modern rate. This places us somewhere how a loss surface. Second is calculate the gradient. We measure how slip how steep the surface in and find the direction of a steepest ascents. Third is update parameter. We take a small step downhill under our update rule and learning rate. Step 4, iterate and coverage. We repeat the process until they change it. Loss because almost zero, meaning we reach the minimum point. This is how the algorithm learn the best value of parameter. Now we see the challenges and consideration. First is local minima. In a complex model, it can get stuck in a small valley inside of a deepest one, leading to suboptimal result. Second is learning rate selection. Closing the right learning rate in a critical to slow means it take a age to fast minimum stability. A third one is a vanishing gradient. It is a deep neural networks gradient can become extremely small, causing easier layer to stop learning. To address their issues, we use a technique like adaptive learning rate and movement due in an advanced optimizer. Now we see the practical application. Where is a gradient descent used? So where do you actually gradient descent? Partially everyone in a machine learning neural network. It just millions of weight in a deep learning model, powering application like image recognition, neural language processing, and Gen AI, means generative AI, linear and logistic regression, used to find the best fit model for a prediction and classification task. And last one is support vector machine, SVMS. Gradient based optimization help a minimum struct risk. In short, gradient descent is a heart of almost every ML algorithm. And the last one is the key getaways and next step. Let's wrap up our the key sessions for today. Loss is a campus. It's measure how far we are from the best solution. Second is gradient is a guide. It's point us in a right direction to reduce error. And the third one is the rate control. Learning rate control the pace. It's decide how fast we reach to goal. In ensure machine learning in all about this dense. Using the gradients of a minimize the loss until we find the perfect balance, the best fit line. Thank you guys.